We're now moving on from simple interest. We're going to move on to compound interest. Now, compound interest, as it says right here in this description, is interest calculated on the principal. So the principal, remember, is just how much money we've put in to save, plus interest earned on prior compounding periods. So what people like to say in compound interest is that you're earning interest on interest. So you get a certain amount of interest put into your bank account if you're saving money, and then your principal actually gets larger. So each time they calculate interest, you're getting more and more interest because you're having more and more in your bank account. The big thing with compound interest is that we talk about something about compound periods, like how often are we being either charged interest or how often is the bank giving us interest. So we're going to jump to the bottom of this page to look at typical compounding periods. So banks could charge you interest if you're borrowing money, or they can give you interest if you're saving money. And these are the periods that are typical and that we'll be talking about here. So we have annual, semi-annual, quarterly, monthly, weekly, and daily. And then we're going to talk about how many times, how many compounding periods this actually happens in a year. So if we're doing an annual compounding period, this is one time per year. They give you interest once a year. Semi-annually, it's twice a year, 2 times a year. Quarterly, that's 4 times a year. So every 3 months, they'd give you interest. Monthly is 12 times per year. There's 12 months in a year. So every month, they dump some more interest into your account. Weekly is the 52 times a year. There's 52 weeks in a year. So every week, they'll give you interest or charge you interest if you're borrowing money. And daily, they'd get interest in your account 365 times per year. So every day, there'd be some interest added to your account. Now, as you could see, if they're giving you interest more frequently, kind of like on a daily interest savings account, this account over a longer period of time would earn a lot more money than just getting interest once a year. Okay, in the beginning stages, it'll look quite similar. It won't make big difference, but if you left it in for years and years and years, you'd start to see that you're going to actually earn more money. So these are the compounding periods we're talking about. Now we jump to the bottom of this page because the compound interest formula, unlike simple interest, is a lot more complex. It's A equals P1 plus I to the exponent of n. And of course, we're going to go through and talk about what each of these actually stand for. So P, just like in simple interest, this is the principal. This is how much money we're actually putting in or borrowing. So that's our principal amount. The I is the interest rate, but it's the interest rate per compounding period. So it's going to take some time to figure out how to actually use this formula. It's a little bit more challenging than the simple interest formula. N stands for the number of compounding periods. And remember, that's an exponent, so we'll have to use our exponent buttons. And A stands for the accumulated amount. Now, accumulated amount means the principal plus any interest that you've earned. So at the end, when you're using this formula, it tells you the principal plus the interest, all put into one. So we're going to take some time, work through these examples, and figure out how we can actually work with this formula. So if I look just at the first example, and I'll show the calculator skills on the side as well, it says calculate the interest you would earn on $1,000 deposited into an account that pays 4% interest per annum. Now remember, per annum just means per year, compounded annually if you left it in for 2 years. So we know that this, because it says compounded, we're going to be using this formula. and we're going to use it, and we're going to find our variables first before we plug anything in. So off to the side, we should know what our principal is in this question. Our principal is the $1,000. That's how much we put in to save. So the principal is $1,000. The I is our interest rate per compounding period. So this says you get 4% per year, and this says they're going to give you interest every year. Now remember, we need to change 4% into a decimal. So 4% actually equals 0.04. And since that's per year, that's how much interest we'll get each time, 4% per year. And the N says it's going to be in there for 2 years. So 2 years, but they're giving you, if you read the question, annual interest. So you're going to get it once a year. So that means over the life of this, you're going to have interest put into your account twice. So let's put that information into our equation. So we're going to find out the accumulated amount. The principal's $1,000. 1 plus 0.04, that's our I, and our exponent is to the power of 2. So you're going to need a calculator that you can actually do a lot of steps with here, and that you plug it in just as you see it. It's going to help you a lot more than using the calculator, say, on your phone. So we're going to go 1,000, open the bracket, 1 plus 0.04, close the bracket. Now my exponent button on my calculator is right above the divide sign. It's this little hat. So I'm going to hit the hat button and say to the power of 2. So as you can see in the calculator, that's how it's supposed to look. And I hit enter, and it's saying the accumulated amount after 2 years is going to be $1,081. And it says 0.6, but remember, money has 2 decimal places, so and 60 cents. So after 2 years, you have more than $1,000, which makes sense. You're saving money. But the question does say calculate the interest I'd get. So it's saying, don't tell me how much is in your account. Tell me how much money the bank actually paid you. So start with the answer we got, the $1,081.60, and say, well, let's subtract the principal. I put in $1,000. So if I do that, that means the amount of interest I earned is $81.60. So the bank paid me $81.60 just to keep that money in my account. So the next question says, compare this to what you would have got with simple interest. So for simple interest, remember, it's interest equals principal times rate times time. And if I look off to the side again, the principal is still $1,000. And the rate that they're giving me is still that 4%, so 0.04. But now the time, it's only in there for 2 years, so we put the t is 2, put it into our equation, we get 1,000 times 0.04 times 2 years. So now the interest I would have got, if it was just simple interest, not compound interest, is 1,000 times the 4% interest times 2 years. And here that would have said I would have only earned $80 interest as opposed to the $81.60 if it was in there compounded. So you can see it's not much difference. It's $1.60 more to put compound interest. That's only for 2 years. If you left this money in for several more years, you'd make more and more money faster through compounding your interest as opposed to just simple interest. The next question, saying calculate the final value of a deposit of $1,000. So right here, deposit of 1,000, that's my principal. Invested at a rate of 2.8% per annum. So this will have something to do with my interest rate for 4 years. This will have something to do with the time in the following compound periods. So now it's important that we know what these compound periods mean. Semi-annually means 2 times a year you're going to get interest. So we're going to look at what that means in terms of our compound interest equation. So here's the compound interest formula. A equals P 1 plus I to the exponent of N. And we're going to go through and we're going to talk about all of our variables. So the principal, we've already said that that's $1,000. Our interest rate is 2.8% per year. So 2.8%, if I divide that by 100, that's 0.028. That's 2%, or sorry, 2.8% a year. But it's in there semi-annually. So they don't give me the 2.8% each time. They say, well, we're giving you interest twice a year, so we're going to give you half of it in the first part, half of it in the second. So if I divide these out, the I'm going to get 0.014 of an interest rate, or 1.4% in the first 6 months, and then 1.4 in the next 6 months. My N, it's in for 4 years, but they're going to give me interest 2 times a year. So that means the bank will actually give me interest 8 times over these 4 years, because it's twice a year. So let's put those numbers into our equation. We still have the $1,000 principal, 1 plus the 0.014 for the interest, to an exponent of 8. So now in our calculator, I'll clear this, and we'll say, well, that's 1,000 times 1 plus 0.014, close the bracket, to the exponent of 8. 8 times they'll give me interest. Hit it, let it calculate it for you, and you get $1,117.64. So that's how much money I'd have in my account after 4 years. I'd make just over $100 worth of interest. Now they're saying, let's compare this to if we did it quarterly. Now, quarterly means 4 times a year. So things are going to be a little different. Again, in this question, we're going to go through and we're going to talk about our formula for compound interest. We'll talk about our variables. We're still putting $1,000 in. The interest rate now, they're still giving me the 2.8%. But now I'm going to divide this by 4, because they're going to give me it 4 times a year. So you could check that on your calculator. 0.028 divided by 4, you get 0.007. And it's important that you don't round this number. You keep all of those decimals for our calculation. So 0.007. Our N, we still have it in for 4 years, the question says, but now since we're getting it quarterly, that means they're going to give us interest 4 times a year. So 4 times 4, I'm going to get interest 16 times over the life of this deposit. So we put our information in. The principal's 1,000. 1 plus 0.007 to the power of 16, because I'll get interest 16 times. Again, I can't stress how important it is to have a good calculator in this situation. 1,000, 1 plus 0.007, close the bracket, to the exponent of 16. Make sure that is an exponent. And this will show me now, after the same time period, but compounding it quarterly, I'm going to have $1,118.08 if you round correctly. So quarterly, I'm getting interest more often, and you can see I make a little bit more money. It's not much, but every little penny in your pocket is a good thing. The last question, monthly. That means 12 times a year, and we're going to compare how that changes now. Same scenario, so there's still our compounding period, and we're still going to talk about a principal of $1,000. The interest rate is still 0.028, but now monthly we're going to divide this by 12. So in our calculator, clearing, we could say 0.028 divided by 12, and that's that large number. And we're saying don't round until the very end, but this is a repeating decimal, so I'd keep a bunch of those 3s for our calculation to help us out. That's our interest rate that we get each month. And our N, it's still in for 4 years, but each year they're giving us interest 12 times. Every month they're going to give us interest. So that is 48 times they'll give us interest through the life of this deposit. So we'll put in the information that we know. We have the $1,000 interest, 1 plus now our interest rate that we calculated is this, to the exponent of 48. So we should see, because we're getting interest more frequently, we should make more money. So $1,000, 1 plus 0.02333, close the bracket, to the exponent of 48. And looking at this, I can see that I must have made a mistake in my calculator somewhere, because this is way out of line with the other ones of like $100 interest. So if I examine what I have in my interest rate, you could see that I put 0.0233 when it should be 0.00233. So always check your answers for reasonableness. So I'm going to go back and fix that mistake. 1,000, 1 plus 0.00233, close the bracket to the power of 48, hit it, and now you could see, yeah, this makes a little bit more sense with what we've been calculating in the previous examples. So we still have $1,118, but now we make 35 cents, rounding correctly. So the difference between quarterly and monthly isn't that much, just a few cents, but you still are making more money if you get your interest compounded more frequently. This is the last example that we're going to go through. And this one's going to take a little bit of calculation on your part, and it's going to take you to keep your work pretty organized throughout here to make it work out. So it's saying calculate the value of an investment of $5,000 that earns an interest rate of 2.95% per annum, compounded semi-annually for 3 years. Use this table to show the value of the investment at the end of each compounding period. So 3 years, if it's in for 3 years and they're doing it semi-annually, that would mean I'd get interest twice a year. That means I'm going to have 6 times where they give me interest. So 1, 2, 3, 4, 5, and 6. And we could say right now the investment at the beginning of the period, right now, our investment is $5,000. And they're saying, let's do it the simple interest formula and adding it on each time. So our interest rate that we're going to use in here is 0.0295, and the time it's in for each time is only half a year, because the time has to match compounding period. So every half a year. So the interest rate, we're going to put it in each time and figure it out. Now we'll go through the first few, and then I'll pause the video and you can figure out where the numbers came from. So each time in this column, we're just going to use this little formula. So we're going to look, I'll put the first few up here. We're going to say the first one, our principal is 5,000. Our interest is 0.0295 for half a year. So we're going to do this number. So we got $5,000 times 0.0295 times by half a year. The interest I'd get for that half a year is $73 and $73.75, which means the investment at the end of that period, you're going to add that on. So I add the $5,000 to that, and I'd have $5,073.75. So that now becomes how much is in my account at the beginning of the next term. So now when we go to do this I equals PRT, instead of the 5,000, now I have $5,073.75 still earning that same interest rate for still another half a year. So now I take the $5,073.75 times it by the interest rate of 2.95% times by another half a year because it's semi-annual. And now we got $74.84 interest. So you can see I've made more money in my interest. And it's important to know that we round to 2 decimal places and we have to round properly. So now at the end, this number here in this cell is these two things added up. I take how much was in my account at the beginning, $5,073.75, and add the new interest rate, which is $74.84, or the interest amount. So now in my account, I have $5,148.59. And that number comes to be how much is in my account at the beginning of the next time. So now we do the same thing, $5,148.59 times by the interest rate times by half a year. So we get $5,148.59 times the interest rate times by the half a year. Means now this time I've earned $75.94. And I just add the 75.94, add it to how much was in my account at the beginning of that line, $5,148.59, which means now after they give me that interest, I now have $5,224.53. And again, that number begins the next line, and we repeat the process. So I would tell you right now to pause the video, complete the chart, and then unpause it, and the answers will be there to check to make sure you're doing it correctly and, more importantly, rounding correctly. So hopefully you paused the video and you went through and finished off the last few rows, and at the end you can see your calculations should have come up with $5,459.14. This is how much money is going to be in your account at the end of these 3 years if you get this interest semi-annually. Now, a chart like this is a lot longer than using the compound interest formula. If you used the compound interest formula, we would have got right down to this same number right away. If the question had asked, well, how much money or how much interest did you actually earn? We take the amount that's in our account, subtract how much we initially put in, and we would have said our interest that we get, so money free from the bank just by putting some savings in, the bank over this time gave us $459.14 interest.